Hello everyone. Chapter 2, Reasoning and Proofs, Section 2.6, Proving Geometric Relationships. We're going to complete this paragraph proof by filling in the blanks. So if two angles are congruent and supplementary, then each is a right angle. That's the statement that we're going to be proving. Whenever we prove a statement or a conditional if-then statement, what we're trying to prove is the conclusion here. So each angle is a right angle. If you notice, we're trying to prove angle W and angle V are right angles. The hypothesis is the given information. So if two angles are congruent and supplementary, that's given. So we have two angles, angle W and angle V are congruent and they're supplementary. Okay, well, what does that mean? Angle 1 is congruent to angle V. They're congruent, so their measures are equal. So the measure of angle W equals the measure of angle V. Angle W and angle V are supplementary. What does that mean? That means the measure of angle W plus the measure of angle V equals 180 degrees. Because angle W and angle V have equal measures, we can substitute angle W for angle V. And when we do that in this statement, we now have the measure of angle W plus the measure of angle W equals 180. That substitution property allows us to do that. Now the book is going to say this next step is simplifying. And I don't think that's descriptive enough. So I require that my students say that going from measure of angle W plus measure of angle W to 2 times the measure of angle W is combining like terms. There's going to be a reason for that. Now, sorry, a little bit too quick. When I go from this statement, what can I do to this? Well, I can take 2 and divide it on both sides, and I'm going to have the measure of angle W equals the measure equals 90 right here. But how did I do that? Well, division property allows me to divide equal things on both sides of the equation. So, since the measure of angle W is equal to the measure of angle V, where angle W is congruent to angle V, if angle W is 90, measure of angle V is 90. If angle W is 90 and angle V is 90, then both are right angles by the definition of right angles. Okay, example 2. I think I can fit this in here. I won't have to go to a separate piece of paper, which I've already done for the other proofs. We're going to write a proof for this form of the congruent supplements theorem. This isn't the form that the book presents our congruent supplements theorem in, but it's just exactly the same, it's just worded a little differently. If two angles are supplementary to congruent angles, then they are congruent. So here I have two angles, angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary, and angle 2 is congruent to angle 4. So angle 1 is supplementary to an angle, that angle 3 is supplementary to that same or congruent angle. So in this case, congruent angles. Our goal is to prove that angle 1 is congruent to angle 3. So I'm going to do that with a statement reason proof. Now my first statement is to recopy the given information. That's 99% of the time that's how we start our proofs. We recopy the given information. Now, because I have a college degree, I can write squigglies. You do not have college degrees, so you have to rewrite all the information. You don't have the luxury of being able to just write squigglies in place of the given information. You have to rewrite the given information. Statement 2. What do we know about this given information? Well, angle 1 and angle 2 is supplementary. That means measure of angle 1 plus the measure of angle 2 equals 180. And same thing for the measure of angle 3 and 4. Measure of angle 3 plus the measure of angle 4 also equals 180. Definition of supplementary angles. Okay, if they're both equal to 180, then they're equal to each other. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Reason 3. What did I do there? Instead of writing 180, I wrote the measure of angle 3 plus the measure of angle 4. Substitution property. Now, and I used to do extra steps here back in the past. I used to, instead of writing angle 4 here, I would replace it with angle 2 because they're congruent. So I would write the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2, and then it would subtract angle 2's from both sides. And I realized I don't need to do that because subtraction property says as long as I subtract equal things from both sides, I'm allowed to do that. It keeps the equation balanced. Well, these things are definitely equal from the given information, so I can subtract angle 2 and angle 4 from both sides of this equation, and I get the measure of angle 1 equals the measure of angle 3. Reason, subtraction property. Now, a lot of students stop here, saying this is what I wanted to prove. It's close. It's not exactly what we wanted to prove, though. We want to prove that angle 1 is congruent to angle 3. So our final statement, angle 1 congruent to angle 3. How do we know that? We know the definition of congruent angles. Alright, we have finished the proof. We've proven what we wanted to prove. What do we write at the end of all proofs? Q, E, D. Quod erat demonstratum. Loosely translated means finished. That which I wanted to demonstrate has been demonstrated. Okay, find the value of each variable and the measure of each labeled angle. Okay, so looking at this diagram, what do we know? Angle Y and angle 2x are vertical angles. According to the vertical angles theorem, they are equal to each other. So Y equals 2x. If I look here, this angle plus this angle add up to give me a straight angle, and by the linear pair postulate, they have to be congruent to each other. They have to be congruent. They are supplementary and adjacent. They have to add up to 180. So the equation that I can write, x plus y plus 5, that's this angle, plus 2x equals 180. I know what y is. Y is 2x. X plus 2x plus 5 plus 2x equals 180. I think I have 5x now. 5x equals 175. X equals 35. And 2 times x is equal to y. So y is equal to 70. And I found the measures of the variables. That makes this 70 degrees, this 70 degrees, and this angle here 110 degrees, because it's got to be supplementary to these two. Okay, so now we want to write our first proof. Our goal is to prove that segment SW is perpendicular to segment RT. SW perpendicular RT. We're given that angle 1 is congruent to angle 2. That's what we're given in this diagram here. So let's go through proof that I've already done for us here. And I did it as a 2-column proof. Piece of paper over here. Actually, I decided to do it as a flow proof. So here we have problem 4. Let's see if we can get a better focus going here. Just want to focus for me today. How about this one? All right, one more time. That's a little bit better. Okay, so I did this second proof here as a flow proof. There are advantages to a flow proof. The advantage to a flow proof is, and I'll show you briefly, flow proof from the answer key. The advantage of the flow proof is you can see this statement came from these two statements combined. Okay, so it tells the story, whereas in a 2-column proof like this, I know where statement 3 came from, but the reader might not know. They have to decipher, where does statement 3 come from? Well, statement 3 came from statement 2 being combined to give us statement 3 here. But there's no physical connection to them as there is in a flow proof. So let's start this flow proof. First thing that I have here is that angle 1 is the measure of angle 1 is equal to the measure of angle 2. That was given information to us. And then if we look at the diagram, we can look at the diagram and say, well, angle 1 and angle 2 are adjacent. Angle 1 and angle 2 add up to be 180 degrees. If they're adjacent and they're supplementary, then the measure of angle 1 plus the measure of angle 2 equals 180 degrees by the linear pair postulate. If I take these two statements now and I combine them in such a way that I'm going to get one new statement. In other words, I'm going to replace this measure of angle 2 with this measure of angle 1 because they're equal to each other. So instead of writing a measure of angle 2 here, I'm going to write measure of angle 1 plus the measure of angle 1 equals 180 degrees. Well, in math, the official term for replacing is substitution. Substitution property allows me to do that replacing. Okay. And now, don't go too far. Measure of angle 1 plus measure of angle 1. 2 times the measure of angle 1 by combining like terms. 2 times the measure of angle 1 equals 180 degrees. What can I do with this statement? I can divide both sides by 2. I get the measure of angle 1 equals 90 by the division property. I'll have to slide up again. Angle 1 is 90 degrees, therefore it is a right angle. How do I know it's a right angle? I know it's a right angle by the definition of a right angle. If angle 1 is a right angle, angle 1 is a right angle, if we look here, angle 1 is a right angle here, then SW is perpendicular to RT. Our final statement, SW is perpendicular to RT. How do I know that SW is perpendicular to RT? Well, I know what the definition of perpendicular lines means. That's the definition of perpendicular is my reason. What do I write at the end of all proofs? QED, quad erat demonstratum. That which I want to demonstrate has been demonstrated. Okay. Example 5 now. So in example 5, What can we conclude from the given information? Well, what is the given information? We're told that the angle RSX and angle YST are complementary, so this angle is complementary to this angle. Add these two together, I get 90 degrees. That's what complementary means. If I add all three angles together, then I get 180 degrees. I get the straight angle RST. Well, if two of those three angles already add up to 90, the third angle must be 90. Therefore, I can conclude angle XSY is a right angle. If angle XSY is a right angle, then ray SX has to be perpendicular to ray SY. SX is perpendicular to SY. So that's example 5. Example 6. Where is that? That's example 6. Example 6, we're going to write a proof that says AO. We're going to write a proof saying that angle 1 is congruent and angle 3 are complements. So angle 1 is a complement to angle 3. That's our goal, is to prove angle 1 is a complement to angle 3. We're told AO, line AO, is perpendicular to line OC, or CO. That means that's a right angle. They're perpendicular. Angles 1 and 2 are complementary. Angles 2 and 3 are vertical. Instead of saying that angle 1 is complementary to angle 2, I can say angle 1 is complementary to angle 3 by substitution. So let's go through and actually do this proof. I did this one as a 2-column proof. So we have example 6. Is a 2-column proof here. Statement 1, again, I did the squigglies. I can do that. You boys and girls can't yet. Gotta get a college degree, you can write squigglies. What do we know when I say AO is perpendicular to CO? What does that mean? What information does that give me? If AO is perpendicular to CO, then here. If AO is perpendicular to CO, then angle AOC is a right angle. How do I know angle AOC is a right angle? I know it's a right angle because I know what the definition of right angles are. I know what the definition of perpendicular is, sorry. We're told that they're perpendicular here. I conclude it's a right angle because of the definition of perpendicular. What do I know about right angles? I know right angles are 90 degrees. How do I know right angles are 90 degrees? I know what the definition of a right angle is. The definition of right angle is an angle whose measure is 90 degrees. So we are about a third of the way, a quarter of the way through the proof. Third of the way through the proof. What can you tell me about angles 1 and 2 in the diagram? Well, angle 1, measure of angle 1 plus the measure of angle 2 equals the measure of angle AOC. Angle 1 plus angle 2 equals the measure of angle AOC. How do I know that? Well, I know the angle addition postulate. Two angles adding up to be a bigger angle. What do I know about the measure of angle AOC? I know it's 90 degrees. Measure of angle 1 plus measure of angle 2 equals 90. How did I know that? Substitution property. I replaced angle AOC with 90 degrees. Okay. What else do I know in this diagram? Well, let's look at angles 2 and 3 here. Angle 2 and angle 3 are vertical angles. According to the vertical angles theorem, they are congruent. Angle 2 is congruent to angle 3. How do I know that again? Vertical angles theorem, VAT. Okay, well, let's take a look here. Angle 1 plus angle 2 equals 90. 2 is equal to 3. Instead of writing 2 here, I can write 3. Measure of angle 1 plus the measure of angle 3 equals 90 degrees. What did I do? Substitution property. I replaced angle 2 with angle 3. Substitution property. Angle 1 and angle 3 equal 90 degrees. What does that mean about angles 1 and 3? It means that they are complementary angles. Angles 1 and 3 are complementary angles. They're complements. How do I know that? I know what the definition of complementary angles is. I'm done with the proof. QED. Quod erat demonstratum. That which I wanted to demonstrate has been demonstrated. Moving on to example 7. By the way, on the answer key, 6 and 7's answers are reversed. Alright. Proof 7. AC perpendicular to BC. Perpendicular. Angle 3 is a complement to angle 1. Angle 3 and angle 1 have to add up to 90 degrees. What about angles 1 and 2? Angles 1 and 2 have to add up to 90 degrees because of this right angle here. Angle 2 plus angle 1 equals 90. Angle 3 plus angle 1 equals 90. Angle 2 and angle 3 have to be congruent to each other. Congruent complements there. Two angles complementary to the same or congruent angles are congruent. I think I did it the long way. I did. I could have done it a little bit quicker. Alright. Example 7. Again, I did it as a statement, reason, 2-column proof. And again, statement 1, squigglies, and given. Statement 2. Let's pull that up. Statement 2. Angle ACB is a right angle. How do I know it's a right angle? Well, my given information says that I have perpendicular. Definition of perpendicular tells me that I have right angles. Definition of perpendicular. If I have a right angle, that angle must be equal 90 degrees. Definition of a right angle. If I look at the diagram, angles 1 and 2 add up to be angle ACB. Measure of angle 1 plus measure of angle 2 equals measure of angle ACB. Angle addition postulate. I know what the measure of angle ACB is. It's 90. Measure of angle 1 plus measure of angle 2 equals 90. Substitution property. At this point, I could do this problem proof one of two different ways. I could now say angle 1 and angle 2 are complements. Angle 1 and angle 2 are complements, definition of complementary angles. Because angle 1 and angle 2 are complements, and angles 1 and 3 are complements, that's up here in the given, then angle 2 and angle 3 Actually, let's do it. Let's write it out. So statement 6, angle 1 and angle 2 are complements. Definition of complementary angles. Okay, statement 7. Because in my given information I have angle 3 is complementary to angle 1, I can now say angle 2 is congruent to angle 3. Reason: congruent complements theorem. From way back here. Congruent complements theorem. Theorem 2.5. Q E D. Now, I didn't do it that way. Instead, I did a little bit different. I went to the definition of complements and said measure of angle 1 plus measure of angle 3 equals 90. Definition of complementary angles. Angle 1 plus angle 2 equals measure of angle 1 plus angle 3. Substitution property. Angle 2, measure of angle 2 plus equals the measure of angle 3. Subtraction property. And finally, angle 2 is congruent to angle 3. Definition of congruent angles, QED. This last part here is the proof for the congruent complements theorem. So I ended up doing more work than I needed to by doing it this way. That's okay. It wasn't wrong, it just was longer. Okay, back to example 8. Alright, we're going to write another proof. Our goal is to say that angle 3 is congruent to angle 5. We're told angle 4 is supplementary to angle 6. If we look at the diagram, 5 and 6 form a linear pair. They must be adjacent and supplementary. So angle 4 is supplementary angle 6, angle 5 is supplementary angle 6. Therefore, angles 4 and 5 must be congruent. That's not what our goal is. Our goal is to say 3 and 5 are congruent. But angles 3 and 4 are vertical angles. They must be congruent. Transitive property is going to get us, or substitution is going to get us angle 3 congruent to angle 5. So if I go with equality, it's going to be substitution. If I go with congruence, it's going to be transitive property. Right. Let's switch my papers out again. That over. Let's take a look at example 8. Example 8 I did as another flow proof. Papers are tough to move today. Alright, so example 8. Let's see if I can refocus again. It's a little bit better, it's about the same. So, example 8, first thing that we're given is measure of angle 5 plus the measure of angle 6 equals 180 degrees. How did I know that? Well, they form a linear pair. They're adjacent. They're supplementary. They add up 180 degrees. Linear pair postulate. What else do we know? Well, angle 4 is supplementary to angle 6. That's given information. Angle 4 is supplementary to angle 6. What does that mean? That means measure of angle 4 plus the measure of angle 6 equals 180 degrees. How do I know that? Definition of supplementary angles. So this statement leads into this statement. But notice now I'm starting two arrows coming out of these two statements, and those arrows are coming together down here in this statement. How do I combine these two statements together? Well, they're both equal to 180, so I can set them equal to each other. Measure of angle 5 plus measure of angle 6 equals measure of angle 4 plus measure of angle 6. How do I know that? Substitution property. Now, this next statement that I have over here, I'll come back to that one. If I look at this, what can I do with this? Well, I have angle 6 on both sides. Subtract angle 6 from both sides, and I get measure of angle 5 equals measure of angle 4. Subtraction property. Back over here, underneath here. What's happening here? Well, angle 3 and angle 4 are vertical angles. Therefore, angle 3 and angle 4 are congruent. How do I know that? Vertical angles theorem. Angle 3 is congruent to angle 4. Measure of angle 4 is equal to measure of angle 5. Angle 3 is congruent to angle 5. Substitution property. That's what I wanted to prove. Therefore, QED. Finished. That which I wanted to demonstrate has been demonstrated. Okay, that was example 8. Let's take a look at our last example, example 9. Measure of angle 1 is equal to the measure of angle 2. Measure of angle 3 is equal to the measure of angle 4. Our goal is to prove that ray OC is perpendicular to line AE. That's our goal, is to prove that these are perpendicular to each other. Okay, well, let's take a look here at what we can do. Angle 1 plus angle 3 is angle AOC. Angle 2 plus angle 4 is angle COE. If I could somehow get angle AOC equal to angle COE, then they would have to both be right angles, and that would make these lines perpendicular. So that's how I'm going to attack this one. So, example 9, I did this one again as I went back to a two-column proof. There we go. So example 9 went back to doing a two-column proof. Again, squigglies, I can do them, you can't. Given information. Okay. From that given information, what do we know about the fact that angle 1 equals angle 2 and angle 3 equals angle 4? So this is a little bit difficult to see, so I'm going to draw this out for you a little bit. Here we have a statement, measure of angle 1 equals measure of angle 2. As long as I keep the left and the right hand side balanced, I can write a new statement. How do I keep it balanced? Well, the different properties of equality allow me to keep things balanced. I can subtract equal things from both sides, I can divide equal things from both sides, I can multiply equal things to both sides, and I can add equal things to both sides. So if I add equal things, something to the left and something to the right that are equal to each other, then I've kept the equation balanced. And the new statement is, again, an equation. Well, what are two things that are equal that I can add one of them to the left and one to the right? Right here. I can add measure of angle 3 to the left-hand side. I can add the measure of angle 4 to the right-hand side. They are equal things. They're going to keep the equation balanced. When I do that, I'm going to get a new statement that is a true statement. Now, what's the advantage of doing that? I'm going to have measure of angle 1 plus the measure of angle 3 on the left-hand side. I'm going to have the measure of angle 2 plus measure of angle 4 on the right-hand side. Hopefully you see where I'm going to be going with that. So, measure of angle 1 plus the measure of angle 3 equals measure of angle 2 plus measure of angle 4. What allowed me to do that? Addition property. Okay. Measure of angle 1 plus measure of angle 3 is equal to measure of angle AOC. Measure of angle 2 plus measure of angle 4 is a measure of angle COE. What allows me to do that? Angle addition postulate. I'm adding two angles, getting a bigger angle. Okay. What can I do with these two statements? Well, instead of writing measure of angle 1 plus measure of angle 3, you can write measure of angle AOC. Instead of writing the measure of angle 2 plus measure of angle 4, you can write the measure of angle COE. You get this new statement. Measure of angle AOC equals measure of angle COE. Reason? Substitution property. Oh, didn't write property. There it is. Okay. What does that do for me? Well, if I look at my original diagram, angle AOC and angle COE form a linear pair. By the linear pair postulate, they have to add up to 180 degrees. Measure of angle AOC plus the measure of angle COE equals 180 degrees. Linear pair postulate. Okay, getting closer. Instead of writing the measure of angle COE, I can replace that with the measure of angle AOC. What allows me to replace things? Substitution property. Measure of angle AOC plus measure of angle AOC. 2 times the measure of angle AOC. Again, the book will say simplify. We write combining like terms, CLT. I can take both sides of this equation and divide it by 2. Get the measure of angle AOC is 90 degrees. Division property. And then finally, ray OC is perpendicular to line AE, definition of perpendicular lines. And at the end of all proofs, QED, quod erat demonstratum. That which I wanted to demonstrate has been demonstrated. That which I wanted to prove has been proven. That which I wanted to show has been shown. Loosely translated means finished. Just like this section. All right, thank you very much, girls and boys. Good luck.